Welcome back to part 2 on Introduction to Right Triangle Trig. Let's first start out by talking about the symbols we use. They are abbreviations for sine, cosine, tangent, cosecant, secant, and cotangent. Those are the 6 basic ratios we will be discussing this quarter, and they will always be referenced with regard to an angle. Usually we'll call that theta, but not always. We've been known to use other Greek letters as well to define these angles. These ratios are the same regardless of the size of the triangle, as we saw in the previous video. So they depend only on theta. And what's very interesting about them is we can write them as we did in the previous video with the reciprocal of the original sine, cosine, and tangent, but we can also write them as a reciprocal of the actual trig ratio that was given. So cosecant of x would equal 1 over sine of x, and secant of x would be 1 over cosine of x. Cotangent of x could be 1 over tangent of x, and tan x, or tangent of x, could equal sine of x over cosine of x. I think you're probably getting the idea, but now cotangent of x, now look at this. Cotangent of x is 1 over tangent. So if tangent of x is sine of x over cosine of x, then if you flip them over, you get this. You see how it flipped it over? Because cotangent of x is 1 over tangent of x. So these got flipped over. So now we have cotangent of x equals cosine of x over sine of x. You probably know what I'm going to say next, which is highlight this and memorize them. The good news is if you memorize these at the beginning of the quarter, by the time you get to the end, they're going to be so second nature to you that you can actually break down any identity that I mentioned, break them down into little pieces that are much more manageable to analyze. So what we have here is relationships, and I think it's important to just very explicitly note this at the beginning of the quarter. You may have had geometry classes or other classes where you've looked at sine, cosine, and tangent, but you haven't really made the leap to recognizing that this sine, cosine, so sine x, cosine x, tangent of x, and a lot of times it can be theta as well. You'll notice that we interchange letters and Greek letters regularly. You can remember that this is opposite over hypotenuse. The cosine x is adjacent over hypotenuse, and tangent is opposite over adjacent. So when we have this is going to sound a little silly, but you'll hear something called SOHCAHTOA trig. SOHCAHTOA trig. So this is sine opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. When you have this SOHCAHTOA trig, we are trying to shift from this concept of, oh, we're just looking for an angle, to recognizing that sine x, cosine x, and tangent x actually represent a distance and a relationship on the unit circle. So you can see that sine of x represents the height here on this sketch of the unit circle with radius 1. Cosine of x represents the width or horizontal change to a location on the edge of the unit circle. Tangent is a ratio of y over x, so O over A, And it gives us a ratio that is tangent to the unit circle. It bumps the unit circle edge, and it is based on the height and width of the angle we're looking at that is formed into a triangle. And then lastly, we have these other relationships. So cotangent, a distance horizontally way out here, where remember cotangent is cosine of x over sine of x. And I think this will become a little more obvious in future videos. I don't want to emphasize that too much right now, but it is interesting to see the relationship of cotangent with respect to the unit circle. Now, we're asked here to find the values of the 6 trigonometric ratios for angle alpha. Told you we were going to change up the Greek letters. Angle alpha in the shown triangle. So here we have this triangle. We first need to figure out where we're going to be standing. So we're standing on the edge here. I've got a little tippy toe on the corner of my alpha angle, and I'm balancing myself so that I don't fall off. And I need to figure out from here where the longest side is. So the longest side is right here. So this is your hypotenuse. I need to figure out which side is my opposite side, and that's the side where I look through the angle. And ta-da, that's my opposite side. And then I need to figure out which side is the side I can walk through, or just go straight onto from this angle. And then this is the only one that's left. So this is my adjacent side. So the adjacent side is this side of length 1. And now I can set up all my 6 trigonometric ratios for angle alpha in the shown triangle. So I know that sine of alpha is opposite over hypotenuse. So it'll be 3 over, we'll call it h. Cosine of alpha will be adjacent over hypotenuse. Tangent of alpha, or we'll say tan alpha, is equal to opposite over adjacent. So 3 over 1, which is simplifying to just 3. Now remember, the other 3 can just be the reciprocals of the first 3. We have cosecant of alpha, which will be hypotenuse over 3. Secant of alpha, which reciprocal of 1 over h is h over 1. And cotangent of alpha is just going to be 1 over 3. Now remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So SOHCAHTOA. And then you just use that to find the other 3. We're not quite done, because if we know the side that is adjacent value, the actual number value, and the value of the opposite side, we can find the value of the hypotenuse, because a squared plus b squared equals c squared, or x squared plus y squared equals r squared. So if we take 1 squared plus 3 squared equals r squared, let's find out what r is. So we have 1 plus 9 equals r squared. So r squared equals 10. If we take the square root of both sides, we get r equals the square root of 10. And that doesn't simplify. So we're going to substitute this value for the hypotenuse. Sine of alpha, let's replace that with 3 over the square root of 10. Now you could rationalize this. I don't know if you remember the rationalization from an intermediate algebra class you may have taken, but rationalizing the denominator would give you 3 root 10 over 10, and that doesn't reduce any further. Now you may be thinking, wow, I never thought I would have to use all this fractional stuff. You do. It doesn't go away. So this one will be 1 over root 10. Cosine of alpha is 1 over hypotenuse, so 1 over root 10. Rationalizing by multiplying by a funny looking 1, 10 over 10, will give us root 10 over 10. The 3 still is a 3. We don't have to do anything to that. And now if we think about this, before I rationalized, the ratio was 3 over 10, root 10 for sine of alpha. So I'm just going to use that for my cosecant alpha because it's just the reciprocal. So I'll have root 10 over 3. Secant alpha will be root 10 over 1, so just root 10. And cotangent of alpha is still just 1/3.